So good afternoon everyone. So in this video we are going to discuss about the response of the first order system. Before going to the response of the first order system, what we should know about the what is the order of the system. Okay, so the highest power of S present in the characteristic equation of a closed loop transfer function of a linear control system is known as uh, order of system. Okay, here the characteristics of a closed loop system, closed loop transfer function of a linear control system is the order of system. Okay, so now first we are going to discuss about the response of the first order system. So already we people know that. So here they will be shown as the canonical form of the black diagram. So in the canonical form of the black diagram, it have summing point as well as block, forward block, as well as takeoff point and feedback block. Okay, so here they are not given any feedback loop, so the feedback block, so that what we have to remember, this is we are going to take it as a 1. Okay, so here we'll discuss the time response of the first order system. So considering so in this following block diagram, so it is the normally we will know it is the closed loop system, and open loop transfer function is connected to the unity feedback. So here we know that transfer function of closed loop system is the C of S by C of output by Laplace transform output by Laplace transform of input. So C of S by R of S is equal to G of S. So forward path divided by G 1 plus G 1 plus G of S into H of S. So here H of S is 1, so that directly we are not taking as H of S over here. Okay, then the next step we are going to apply the G of S value. So it will become G of S is equal to 1 by ST. Okay, so C of S, substitute in this equation, it will become C of S by R of S is equal to 1 by ST divided by 1 plus 1 by ST. So while simplifying the denominator, it will become ST plus 1 divided by ST. So ST get cancelled. So this equation it will become 1 by ST plus 1. So here the power of S is one of the denominator term, hence the above equation is the first order and the system said to be the first order system. Okay, so this equation we can rewrite as a C of S is equal to that is the output is equal to 1 by ST plus 1 into input, that is the R of S. Okay, so this is the first order system. Okay, now here already we people know that C of S is the Laplace transform of output, R of S is the Laplace transform of input of the input signal R of t. Here t is the time constant. Okay, the following steps get response the output of the first order system of time domain. So take the Laplace transform of input signal R of t. Consider the equation C of S is equal to 1 by ST plus 1 into R of S. So here substitute the R of S value into the above equation. Do the partial fraction. C of S is required. Apply the Laplace transform to C of S. Okay, so here impulse response of first order system. Consider the unit impulse signal the to the input first order system. R of t is equal to del of t is equal to, apply the Laplace transform on both the side. R of s is equal to 1. So consider the equation C of S is equal to 1 by ST plus 1 into R of S. So R of S is equal to 1. We are going to substitute into the main equation. So C of S is equal to 1 by ST plus 1 into 1. So this equation it become 1 by ST plus 1. Okay. So rearrange the above equation in one of the standard form in the Laplace equation. C of S is equal to 1 by t into s plus 1 by t. So C of s is equal to, so 1 by t we are going to take it as a common, so that it will become 1 by s plus 1 by t. So applying the inverse Laplace transform of both the sides, C of t is equal to, so why, because of already we are taking as a Laplace transform to convert the time domain into the frequency domain. So Here opposite we are going to do. So frequency domain into time domain. C of t is equal to 1 by t into e power of minus t by t into u of t. So the unit impulse response shown in the following figure. So it will be gradually, so it will be gradually decreasing over here towards to the time. So the unit impulse response C of t is the exponential decaying of signal for positive values t, and it is 0 for negative for t values. Okay, then we are going to discuss about the step response for the first order system. So here consider the unit step signal for the input first order system. R of t is equal to u of t. So apply the Laplace transform of both the side. R of s is equal to 1 by s. Consider the equation C of s is equal to, so 1 by st plus 1 into r of s. So substitute the r of s value is in the 1 by s. So that you can substitute into the r of s over here. So this equation it will becomes 1 by s into st plus 1. Okay. So then here we are going to take the partial fractions over here. So C of s is equal to 1 by s into st plus 1 is equal to a by s plus b by st plus 1. So this equation it will become taking common LCM. So a into st plus 1 plus bs divided by s into st plus 1. So on both the sides the denominator term is the same. So go get cancelled, so that this they will be cancelled by each other. So equation numerator it will be 1 is equal to a into st plus 1 plus bs. So by equating the constant term of both the sides, we will get a is equal to 1. Substitute a is equal to 1 and equations equate the coefficient of s terms in the both the sides. So a is equal to 1 means this equation it will becomes 0 is equal to t plus b. So b is equal to minus t. So here substitute a is equal to 1, b is equal to minus t. The partial exponent c of s, c of s is equal to 1 by s minus t by s t plus 1 is equal to 1 by s minus t by t into s plus 1 by t. So c of s is equal to 1 by s in minus 1 by s plus 1 by t. So apply the inverse Laplace transform of both the sides. C of t is equal to 1 minus e power of minus t by capital T is into u of t. So the unit step response C of t of the both the transient and steady state terms, the transient term unit step response is the CTR of t is equal to minus minus e of power minus of t by t into u of t. So here the steady state term in the unit step response, see as a steady state response of t is equal to u of t. The following figure shows the unit response time. So if you see over here, the signal gradually increases towards to the time. Okay, so the value of unit step response of t is equal to 0. T is equal to 0 for all negative values. So it is the gradually increasing from 0 value to finally it reaches it 1 in steady state. So the steady state value depends on the magnitude of uh, the input. Okay, so this is about the step response of first order system.